Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. My name is Neeraj Kedia, and I've been working in this IT industry for more than 12 years now. The main agenda for today's session is we are going to discuss on the concepts of snapshots and AMIs, why exactly we require autoscaling, what exactly is autoscaling all about, what is a load balancer, and then we are going to see the hands-on on top of it. That's the main agenda for today's session for which we have gathered. So first of all, why AWS? Because AWS, as compared to other cloud computing providers, like we have GCP, Microsoft Azure, AWS has a bigger market share than all the other cloud computing platforms. And in terms of the server capacity, AWS has 6 times more computation power than all the other cloud computing platforms combined. That's again the power of AWS that it has. Whereas in terms of the pricing, again, it has much flexible pricing that we can choose for different use cases. We can go for reserve pricing, we can pay upfront, we can pay on demand basis. Depending upon the customer, depending on the budget that we have, we can choose the payment method accordingly. And what exactly is AWS? AWS, as we know, is the world's leading cloud computing platform that is having a market share of around 40%, then followed by Microsoft Azure having a market share of around 22%, then followed by GCP having a market share of around 11%. And then all the other cloud computing platforms like we have from IBM, VMware, DigitalOcean, and multiple other service providers. And AWS has been a global leader since its introduction back in 2006. And since then, it has been a global leader for the entire cloud computing services. And currently, there are 157 plus services that AWS has to offer for different categories, for computation, for storage, for networking, for databases, for IoT, for AR/VR. There are multiple categories, and in total, there are more than 157 plus services that is being given by AWS. And there are different domains available in AWS. So we have different category of services, like we can browse through the AWS platform to see the list of computation services, migration services, security and identity compliances for storage, networking and content delivery, messaging, databases, and management tools. So if you want to see the entire detail, like for example, the details for each and every service in depth, then you can also refer to a link called as aws.amazon.com. So let me showcase you. So if we go to this entire platform, we will be able to see the list of all the services offered here in different categories. So here we can see the list of the analytics, application integration, AR/VR, cost management, customer engagement, computation services. We have different services that we can go for. And for migration transfer, for media services, for end user computation, for gaming tech, for Internet of Things, they have multiple services that we have available as a part of the entire services offered by AWS. Now, since our main agenda for today's session is to discuss on AWS autoscaling, so let's get started with that. So first of all, let's discuss on the concept of snapshots and AMIs. So snapshots are like incremental backups, which we can take for the servers, for the storage, for the RDS instance as well that we deploy, right? So basically, we know if we talk about snapshot, then snapshots only capture data that has been written to your EBS volume at the time of snapshot command is used, correct? So once the snapshot command has been used here, and then we can create an AMI out of it. AMI refers to the image. That means whenever we are launching any servers, obviously we do need to choose we can say a base AMI, as in base image. Just like every PC needs to have an operating system, correct? And apart from the operating system, we can choose what other configurations we need. So for example, we want to migrate, we want to make a copy of this entire system. So in this system, we are running Windows. And apart from Windows, we have also configured the entire MS Office. We have also configured multiple changes. We have also customized each and every component here. We also have the entire application suite for photos and video editing. We have suite for the networking device softwares. We have the applications for antivirus for complete security. And now we want to make a copy of this entire system with every piece of configuration that we have done along with our own data. then we can create an image out of it. We can create an image out of it, and then we can use this image, just like we have a disk image. So we can use this image on any particular system, so that whichever system, whichever server we deploy this image on, that is going to act like a replica of the current instance that we have taken a snapshot of. And that exactly is what we do by using the concept of snapshot and the AMIs. So using snapshot, we can get the exact data for which we have taken the snapshot for. And then using the snapshot, that means using that backup, we can create an AMI out of it. So that again, we can use this entire AMI, and basically here it will make sure that whatever snapshot we have taken up, that AMI has to be updated, and whatever is present in that AMI, whatever configuration, whatever application data, that should be used when we are trying to launch any new servers. So for example, when we are done getting the image, so obviously whatever data we have stored in this image, that itself is going to be replicated in the servers on which we are trying to deploy it. Correct? So that exactly is what we mean by snapshots, and also on top of AMI, as in Amazon Machine Image. Now, here in order to see the entire AMI, for example, let's say we have deployed a virtual server just like we have EC2 instance. So in case we already are familiar with EC2 instance, correct? So EC2 is basically a service that is used for launching the virtual servers in AWS, correct? So for example, we have deployed an EC2 instance, and on this entire instance, we have installed WordPress, and before we can install WordPress, we had installed PHP server, we had installed the Apache server, it is HTTP, we installed the MySQL instance as well. We did create a complete separate database instance on top of it. Then we have installed WordPress, we had customized it, we installed multiple plugins and extensions, and all the entire dataset has been made available on top of it, correct? Including all the changes in terms of the content. That means these all configurations have been done by us, correct? Now we want that now this is done entirely on a single server. This is only a single server, correct? Now we want that now we are going to host this for the website for the public usage. Now we want that this entire server copy should be deployed whenever there is increased load, because that's a concept of auto scaling we are going to discuss. So for example, we want that whenever the CPU usage goes beyond 60%, we want a copy of this entire instance should be launched, so that the entire load can be shared in this newly created instance, which is currently the exact copy of whatever we have done in the main instance, that should be replicated in the newly deployed server, so that this server can also be used for handle traffic which we are getting from the public, correct? So in order to create a complete replica of the current instance, there are two options. Either we have to configure each and every server and copy the entire data set one by one. We can do that manually, or we can create something called a snapshot. So snapshot will save each and every configuration out of it, and using this, because snapshot is like a backup, and using that snapshot, we can create something called as image, as AMI. So when we are launching this instance, we can simply choose the AMI that we want to use for launching the instance, and whatever data, whatever configuration has been available in this AMI will be used when we are trying to launch the server. So, and then we can choose to launch multiple servers exactly as per the requirement. And that exactly is what snapshots and AMIs are useful for. So first of all, let's discuss on why do we need auto-scaling components. So auto-scaling is basically required just the way that we have seen. We have an e-commerce store, and by default, this single server is good for managing, let's say, 3 users. And now the entire list of the number of users, it got increased because of sales or popularity. Now the single server is not enough to handle the increased number of requests. So using auto-scaling, we can launch more number of servers in order to handle the increased usage, or we can say increased number of users or increased number of requests coming into the same instance type. And what exactly is auto-scaling? So auto-scaling is basically increasing or decreasing the number of servers so that we can handle the increased load. And now when we increase the servers, obviously we are going to decrease the servers as well, because suppose if the number of users increase from 1,000 to 3,000, so we added 2 more servers. And whenever the the same traffic reduces back to 1000, at that point also we need to remove those additional servers that we had deployed, because if we don't do that, our cost here is going to be increased, correct? Which we definitely do not want. And that's why we have to make a balance between both the increasing and decreasing the number of servers as well as a part of auto scaling. All right. And what exactly is a load balancer? So now load balancer, you're using load balancer, we can simply divide the entire traffic among multiple instances. So that means, suppose if we have three different application servers, we have three different web servers. We have three different web servers, and now we want that the traffic in these three web servers should be equally divided. Then we can add them as a part of the load balancer, as a part of the ELB. ELB refers to elastic load balancer, and then we can distribute the entire load among these three servers individually. That we can do as a part of load balancing. So whatever amount of traffic is coming in, we can distribute the entire load in these different servers accordingly as a part of load balancers. So as we discussed now here, once we increase the number of servers, so obviously we want to have a configuration, we can say a management through which we can distribute the entire load in multiple servers. So all the requests coming in can be handled, can be well distributed in all the resources that we had deployed all through the components of load balancers. Now, to handle the web requests, we have two types of load balancers available. Like we have classic and then we have application. So classic handles the load balancer in terms of simple distribution of load among multiple instances. For example, we have a requirement of distribute load among 2 instances, among 3 instances, among 5 instances. Then we can, without any logic. That means here we don't want to provide any logic. Okay, we don't want to send the traffic coming in from one path to the one instance and the other part to the other instance. We don't want to apply any logic based on listeners as well. That means suppose traffic coming into port 80 should be going to some other servers, and traffic coming to port 8080 should be going to some other servers. So if we don't want these kind of advanced configuration, we want to keep it simple based on the round robin algorithm, then we can use the concept of classic load balancer. Whereas if we want to provide multiple logics, for example, we want the traffic coming in, suppose from a specific page, as in .com/page1 should be going to one group of instances, and traffic coming in, suppose to a different page, they should be going to some other instances. We want the traffic coming in, suppose from a specific port, should be handled by one service, by one particular group of instances. Then we can, these advanced configuration we can achieve all through the concept of application load balancers. Whereas in classic, we can keep things simple as a part of the classic load balancer distribution. So now as a part of the hands-on, we are going to see how we can set up the entire application load balancer, where we are going to look at how we can set up path-based routing. That means if we are sending that now, if we have a domain, and again now if we want to send the traffic coming to page 1 to some other group of servers, and if the traffic is coming to page 2, then they should be handled by some other servers. So this entire distribution of load is something that we are going to discuss as a part of our today's hands-on. All right, so now let's see how we can apply the concept of load balancing. So for doing that, we have to come down to our console. So we can open up our console here. So now in case you don't have the access to the console, you can always sign up for a free tier account, which will give you access to the resources, and that too under a specific limit. We can do that. All right. So currently we are in a console here. So now we are in the console. So now we can go to the service tab. So before we can even start deployment of the auto scaling, we have to launch a couple of servers. So here we can open up the server here. So for using servers, we can open up the EC2 dashboard where we can define to launch any number of instances. So here we can click on running instance to see the list of all the instances that we have seen. And now we want to launch new instance, we can click on launch instance, and then we can choose the AMI. Now AMI is, as we already are well aware of, we can choose any of the AMIs such as, now suppose here in this example, we want to use any of the CMS based AMI, then we can choose any other CMS based AMI, right? For example, here we can see, here we have results in marketplace. So we can choose any of the AMIs, as in we can choose community AMIs, which are, as we have already discussed, these are already license free. Now, let's choose this AMI because now why we are choosing those, we are going to choose two AMIs as we had discussed earlier, because at the end, when we are launching the auto scaling component, obviously we launch the same type of instance, right? But again, if we use the same type of instance on two different servers, like we had discussed this already. So if we choose the same server, it's the same AMI on two different instances here, correct? And now if we use it for load balancing, then load balancing will happen, but we will not be able to see how the load is being shifted from one instance to the other, correct? And that's why we are going to deploy one instance that will be running on, let's say, on WordPress, whereas the other instance will be running on Joomla, so that whenever we see the entire hands-on in a live use case, we can see the load being distributed in these different two instances accordingly, correct? So here, that's why we are choosing two different AMIs here for seeing the actual hands-on how these things are distributed. So now we can configure instance detail. We want to launch only one instance, not more than that. And then we can define the security group, which already has the access to the HTTP and HTTPS protocol for seeing this in browser. And then when we are trying to launch any server, we can simply choose a key pair. So since we don't have any key pair yet, so we can click on create new key pair. Let's say we name it as today's date as June 11, so that we don't have any confusion. We can download the key pair, because again, in case you want to use this for getting the access through SSH, then we can use this particular set of key pair as well. We can do that. Now we can click on view instance. Now this is the earlier instance that we deployed here. Now one is running on WordPress and the other one is going to run on Joomla that we are going to see as a part of the entire hands-on. So this, now we can name it, just so it can avoid confusion, we can name it as WordPress, and the other one we can name as Joomla, just to avoid confusion. Because again, if you don't name them, again, that means we are going to have confusion when we are trying to add them in our instance group. Now these two have been added. Now we can get the IP address that we have seen. Now once we get the IP address, we can see this AMIs, or we can see the servers available, or can say being open in the browser. We can do that. Now once we define these two instances, now we can define the load balancer. So for defining load balancer, we had discussed, we can scroll down towards the end, and here we have the component of load balancer. Now once we are in load balancer, we can click on create load balancer, and these are three different load balancer that we can choose from: classic, network, and application. So now since the requirement is for application, we can click on application load balancer. Here we can define the name. Now just to avoid confusion, let's name it as application itself, just to avoid confusion, as application load balancer. We can create application load balancer here. All right, so now here we can see, here we have the application load balancer with us. So now we can define this as application. Now here we can define what kind of, now this is going to be internal or Indian facing that we had discussed already. So internal facing, we generally go for internal distribution of load. For example, we discussed this pointer earlier. So for example, if we are deploying multi-tier architecture, and we know that, okay, we have our web servers that we can deploy in the public subnet, and then we have multiple web servers. And now if we have multiple application servers that we have deployed in our private subnet, now we want to distribute the load of web servers internally to multiple application servers and database as well. Then for that use case, we can use the internal load balancer that we have seen. So for now, we are going to see the entire load-based distribution for the front-facing internet, right? So here we can keep it to intent-facing for now to avoid confusion. And then we can choose the listeners. That means currently, since we are now, if we want, we can add more listeners that we have seen. We can add 4 listeners for port 80, for port 8080. We can add multiple listeners as per the requirement. And then we can proceed further in configuration of the security groups. We can define that. So security groups, as we had discussed already, so security groups are basically used for defining the access. That means this particular instance or load balancer will be having the access to which particular protocol. So whatever protocol we want to give the access to, we can define those security groups. We can choose any of the existing security group, or we can go ahead and create a new security group as well. We can do that. For example, here we can define new security. We can choose the protocol, the port range, and the source, where exactly we want to create that. Now we want to keep it for public because since this is going to handle the public facing application, so we can keep it to the port only, just to avoid confusion. But if we want to add more number of rules, we can choose any of the any of the protocol that we have configured so far. We can choose any of these protocols. Then we have to simply register targets. Now we have discussed that in application load balancer, we can create multiple groups, right? So we can create multiple groups and these are called as target groups that we discussed. So these target groups now instead of we can say dividing the entire load to individual instance, we have discussed we can create multiple target groups. And in this target group, we can add multiple instances so that suppose we have defined one logic as if any traffic is coming from page one, then that page one traffic should be handled to the entire group itself, not to individual instances. And we want that page two should be handled by another group of instance. Then for that, we have to create a separate target group, right? So we can create target groups. Now by default, when we are creating the load balancer we had discussed, we can choose one target group. We cannot add the same target group to multiple load balancers. So one target group can be added to only one type of load balancer, correct? And so here we can define the name. That means what exactly we are going to create here. For example, let's suppose here we have target. We can define multiple target groups. So for example, here we can define target one and target two. Now, obviously, we are going to create these different target groups at a later stage. We can define that. And then we can choose the target type as instance, IP, Lambda function. We can choose accordingly. We can choose a protocol for the given target that we are trying to add. And application load balancers, they support the WebSockets. So that's why we have HTTP and HTTPS protocols added. And here then we have the two register targets. So here we can define the health check and then we can define register targets. So basically here we can add any number of instances. Now currently we have defined only one target group, correct? So same principle that we have followed. We are going to add one instance to one target group and the other instance to other target group so that we can see the actual load being shifted. Because for load distribution, we need to have at least two different target groups, right? As we discussed. So we can choose this one, and then we are going to choose the other one in the, for example, in other group, right? So again, for one instance, for one target group, we are going to create Joomla, and for the other one, we are going to create, let's say, WordPress, right? So we are going to create one different target groups for every instance here. So once we define that, we can click on review, where we can review each and every parameter that we have defined for the given instance. And now we can click on create. So now we can see the entire load balancer in place here. So this application load balancer has been created. And now we can see currently it is being provisioned here. All right, so now here we can define, now here once we define this application load balancer, we are going to get the entire DNS through which we can get connected. But this entire application load balancer is currently having only one listener defined, where we are having only one particular target group also defined. So we have to have at least two target groups, correct? So here we can define target group. To see the list of target groups available, we can come down to target groups. Here we can see the entire list. And to add more target groups, we have to click on create target groups, correct? So we already have one target group. Here we can click on create target group. Let's name it as target one. And then once we define target one, then we have to choose a protocol, the port, the VPC, the health check, everything will remain same exactly as it is. And now we can click on create. Once we are done, we can click on create here, and this is going to create the entire target group for us. So we have both target one and target two. So now we can, now in target two, we already have the instance added. So we can come down to targets and we can see WordPress instance is already defined in target, right? So now in target one, we also have to add another instance. So for target one, let's add the instance for Joomla. So for adding it, we can click on edit. And here from the list, we can choose Joomla as the instance that we are trying to add. Click on add to registered. And then we can click on save to simply save the entire parameter here. So once we save it, we will be able to see the entire instance being added here. So you can see now Joomla has been added for target 1, whereas for target 2, we are defined this as WordPress. So now we have two different target groups which we defined for the load balancer, correct? Which we defined for the load balancer. And now if we see the entire DNS now if you go back to the entire description, we are going to get the entire DNS for the given load balancer that we can use, right? So if you go back to load balancer or contains only one particular rule here, that is defining each and every traffic should be routed to target group 2. So now we also need to define a rule. That means for now this rule can be path-based rule, this can be any condition that we want to fulfill. So we want, now here we have defined that target 2 should be handling the entire traffic. But now we want to add rules. So here we can click on add rule, insert rule, and here we can choose a rule that we want to configure. As now here we can choose the condition here. That means here we can choose, suppose here we can choose path-based routing. We want that if someone comes into for let's suppose page 1, then they should be handled, then should be directed to some other target groups. Then we can define the entire logic, and here we can add multiple values as page 1 or page 2 or any specific page. For example, here we can define the logic. Suppose if we want to send if we have a website and a website has the application page, if a website has the page for, let's say, for application, so one page is hosting the application which is allowing the users to upload their photos and make the changes. So obviously that application needs to have a good capacity server, and whereas all the other pages are simple information based pages, so they don't need a high end server, so they can be deployed on, let's say, T2 family. So for these type of different configurations, we can define the entire traffic, how exactly they are going to be distributed, right? Once we save the logic, here we can click on save, and then we can define action. So in action, we can define what kind of action we want. We want them to forward to, or suppose redirect to. We can define forward to, and here we can choose a target group. Suppose any kind of traffic coming into page 1. Suppose let's define that. So for page 1, we do have to add a / because then until as we do that, that won't be treated like a traffic, or we can say a complete traffic here. We can say the complete path. So here we define for page 1. And again, if you want, suppose if you want to be something else, we can add a complete path. For example, we want someone coming from page 1 and that to suppose as ABC. Then again, it should be handed to the entire logic should be this one itself. So for example, if you have a longer path or shorter path, it doesn't matter. So we want that anyone coming from page 1, they should be handled to some other pages. So we can define the path. And then once we define the path here, we can simply click on save. We can define it should be forwarded to, let's say, target group 1, as we have already defined target 2. So here we can choose target 1. And if we have multiple target groups, we can define those, and then we can allow the weight-based distribution as well, as we discussed. And group level stickiness is when we want to stick when we want the users to stick to a particular server for a given time period, then we can enable the group level stickiness, right? We can define those group level stickiness. We can define that. And then once we are done, we can click on save. Here we can save it. And once we save the entire logic, once you click on save here, this entire logic is going to get updated. So as you can see, this entire logic has now been updated. So that means any traffic coming from parts from page 1, that should be sent to target group 1, whereas any other request should be handled to target 2 itself. That exactly is what we define. Now to see this in action, we can come back to our load balancer. We can go to the description tab. So here we can see in description tab, we have the DNS name. So we can copy the DNS, and here in the browser, we can open up the DNS because this is a DNS of the load balancer that we have defined here. And if we press enter, we would be, first of all, we would be able to see the DNS of the default load balancer that we have copied, or we can say the default group that we defined. So as we can see here we have the WordPress instance that we are going to see here. As per the load balancer, we are seeing the WordPress instance. And now we have defined logic as someone coming from page 1. Now, before we see that, let's also see how exactly the page for Joomla also looks like. Then only we can see what was the other instance that we defined the traffic for. So we can see the other instance. So we had launched 2 instances, one for running on WordPress and the other one was running on top of EC2, correct? So here for WordPress, this is the home page. For WordPress, this is the home page, right? That we have seen as a part of the target 2 that we defined. And for Joomla, we had this instance. We can copy the IP in the browser. So this is the IP address for Joomla. That means now if we define page 2, we are going to see the instance. Now this is for users blog. The earlier WordPress was for users blog, and this is for the Joomla, containing for the 2020 user site, correct? That means now if we go back to our load balancer, if we type in the address, as whatever we have seen just now, let's go back to our load balancer. So now in load balancer, we have the same DNS that we have copied, correct? So if we copy the same load balancer DNS, let's close these unwanted tabs. Now by default, if you open the DNS name here address in the bar, then we would be able to see the WordPress instance because it is getting directed to page 2, the second instance, right? Target group 2. But here, if in the path we define something as page 1, this is going to take us to the other instance that was for the other target group that we defined here. Now this, as we can see here, this is for user site that was running on Joomla. But why it says page not found? Because in Joomla instance, there is no definite page defined as page 1. If in case there was a page 1 defined, then this would have opened a page 1 for us to see the entire hands-on here as a part of how we can achieve the load balancing as a part of the component for AWS that we have discussed so far. Okay, sure. Let's quickly see the auto scaling as well. Before auto scaling, we have to define the launch configuration. As we discussed, auto scaling requires launch configuration. So here we can choose launch configuration first by going back into the EC2 dashboard. Because using launch configuration that we discussed, so when we are trying to launch any number of servers, we do need to define the entire configuration. That means when we launch any EC2 service, we have to define what kind of AMI we want to launch, what kind of configuration of servers we want to launch. So we have to take care of each and every parameter, correct? So for example, we want to choose any of the current AMIs. For example, let's say here we want to deploy WordPress. For example, if we have our own custom AMIs, then we can choose a custom AMI because practically we choose our own AMI because we want the exact copy of the servers which are running to be launched whenever any new servers are needed, correct? And that exactly is what we have deployed here, correct? So here for launching, for example, here we can search for the same WordPress. Let's suppose we want to launch WordPress-based AMIs. So here we can choose WordPress in Marketplace, not in My AMIs, in Marketplace. We want to use the same WordPress-based AMIs. And then in WordPress-based AMIs, we can choose the exact configuration that we want. And same way we launch the entire servers, we can configure the each and every instance detail here. We want how many number of servers. Here we can define the name of the template that we want. As in, suppose here we want to define as launch template. Let's name it as launch template only, as launch template. And then we can define the role. If you want to enable monitoring, let's keep it for now. But again, practically we do enable the monitoring for each and every activity happening on the instance. Then we can choose the entire configuration in terms of storage. We can define the security groups. We can review each and every parameter that we have done. And here we can see the entire configuration. And once we click on launch configuration, we are going to launch the configuration with the exact change that we have defined. Here we can choose a key pair that we want to use. And here we can click on launch configuration. Once we choose the same key file, once we click it, we are going to see the launch configuration being created. As you can see, this launch configuration has been created. Now we can use this. Now, once we define this in the launch configuration, now we can use this launch configuration to launch any number of autoscaling group. Because whenever any new server is required, this launch configuration is going to be used for launching that instance. So once we are done, we can simply scroll down. Here we can see autoscaling group. And here we now for creating the autoscaling group here, we have to click on autoscaling group. So this autoscaling group is something that we are going to create by using the launch configuration template that we have already declared, right? So here we are going to use this template. Click on next. All right, so here we can see the entire autoscaling component. So here we can define the name here for the group that we are going to launch. So let's say we name it as launch SC itself. For example, here we can name it as auto scaling itself. Just to avoid confusion, let's name it as auto scaling group itself. And then we can define the network, the group size. So here we can define with how much of group, or we can say instance, we want to launch the instance. We want to launch with 3 instances or 5 instances. We can define the number here. That means minimum, it is going to launch the entire group here with 3 instances. And then we can choose a subnet, because every zone has multiple subnets as in zones. So we can choose in the given network, in the given VPC, which all subnets we are going to use here. Click on configure instance detail. And if you want to use a component for auto scaling, we can choose the option for use the scaling policies to adjust the capacity of this group. We can use this. Where we have scaling between and scaling, here we have the option scale between minimum and maximum number of instances. That means here if we want to define, okay, how many instances we want to launch and how many instances we want to stop it. For example, here we can define minimum and maximum. We want to scale to 10. We can define the entire maximum capacity as 10 itself. So we had discussed this pointer. Now, minimum is that what we are going to create, and maximum is the maximum capacity that we want to cap the limit to, right? For example, let's say we want that in a given instance, in a given target group, we want to maintain at least 3 instances up and running should be there at any time. That means if for any reason, if any of these, suppose if 2 instances they are stopped, then again, since we define the minimum number as 3 here, that means it will try to make sure that again the 3 number is maintained. So it is going to launch 2 more instances to match that particular number that we discussed already, right? That means the minimum number is going to be 3 here, and maximum when you define it as 10. That means here we want that if there are 4 servers, 5 servers, 10 servers. So here it is going to, now at max, it is going to contain only 10 servers. So if there is an 11 servers being launched here, then it is going to simply terminate that 11 server to maintain the maximum number to be 10. Because we don't want to, now, although we want to maintain the performance, but we don't want to increase our billing as well. We have a budget only of 10 instances at max, correct? So here, that's why we have defined the entire limit that we see. So once we define the maximum and minimum number, then we can choose the entire scaling policies. For example, here we can choose the increased group size and decreased group size. So increased group size, we can, first of all, we have to define the logic because we want this to be automated, correct? So here we can define the alarm here as add alarm. And then we can choose the, if you want the entire, if this condition is fulfilled, then we should be notified. Then we can keep it to yes. So if we choose notification, then we use the SNS based notification that we had discussed just a moment. So here we can see the entire logic here. For example, we want that minimum number of, so here we can define if we want the average, minimum, maximum. So we want that if we average CPU utilization, or we can choose from maximum disk read, network in, network out, and we want is greater than or equal to suppose 60%. Then we want that, let's suppose here we define as 60%, then we want that, and that took for at least for consecutive 1 minute. All right. So here we can define that if the condition is there for at least for 1 minute, for example, 1 consecutive period of 5 minutes, then it should, and then this entire condition should be fulfilled. So here we can click on create alarm. And then same way here we can define if the condition is fulfilled, that means if CPU usage is beyond 60, or we can say is greater than or equal to 60 for 300 seconds, then it is going to add more number of servers. Then it is going to add more number of servers. So here we can define add 5 capacity units. We can define that means it is going to launch 5 more servers, or suppose 2 more servers. We can define the entire limit here. So again, if this condition is fulfilled, it is going to add 2 more servers. And then we also have to define the scaling down as well. So once we increase in that servers, obviously we also have to decrease the servers as well. So here we can define the same alarm set. So here we can click on add alarm, and here we can define, suppose we had defined, okay, an average if the CPU is greater than or equal to, then it is going to add 2 more servers. So here we can define if average CPU suppose is less than 60%. So here we can define if the CPU usage is less than 60%, then it is going to add 2 more servers, and that is for a consecutive period of the suppose 15 minutes. So then it is going to add, remove those servers. So here we can define remove 2. That means here it is going to remove the 2 additional servers which was launched by the increased group size, right? And then once we click on configure notifications, we can choose if you want to get notified or not. We can choose. We can configure tasks. Tasks, as we discussed, it is one of the most important component. Click on review. And then we can define the entire auto-scaling group that we want to create here. So once we click on create here, we can see the entire auto-scaling group will be deployed that we can use with any particular auto-scaling group, or we can say target group that we define here. So you can see this entire auto-scaling group currently created. And now if we want to use for using it, we simply have to make sure that we can click on actions, edit, and then we can simply attach this to any particular load balancer or any classic load balancer or any target group. And for example, if you want that this one should be added to the target group 1, then we can click on save. That means whatever logic we defined for this load balancer is now going to be applied for that given target group. All right. So that's how the entire component of autoscaling is structured, and that's how the entire autoscaling component is built on top of AWS. And it is always advisable, guys, in case you are using the feature access. So once we are done, it is always advisable to remove the autoscaling components here. Because if you keep on the autoscaling component active, then it is going to add the number of minimum instances every now and then. So obviously, if you don't want to get billed, you have to simply work on removing all the servers and all the different components that you have created just now to avoid getting billed in case you want to restrict yourself in the feature access. So obviously, so simply choose all the instances, click on instance state and terminate, and delete all the load balancers and all the launch configuration template as well to avoid getting billed. All right, so I guess it's almost time now. So let's say we wrap it up for today, guys. Thank you so much for joining and have a great day ahead. Take care. Bye-bye.